Hi everyone. In this video, I will be demonstrating image classification using traditional convolutional neural network method and fast AI. I will be giving a brief introduction about what is image classification. The answer lies in the words image is a visual representation of something and classification is the action or process of grouping objects according to shared qualities or characteristics. There are two images here. By seeing the images, you would have recognized it as a golden retriever and the other one as an apple. But how do you think you can make a machine recognize it? This is where neural networks come into picture, and this is what image classification is about. We use labeled images to train a model. That is, image of an apple will be labeled as an apple and the other objects would be labeled respectively. So let's see about convolutional neural network. In deep learning, a CNN is a class of deep neural networks commonly applied to analyze visual imagery. The name convolutional neural network indicates that the network employs a mathematical operation called convolution. Convolution is a specialized kind of linear operation. A CNN consists of an input layer and an output layer as well as hidden layers. The hidden layers of a CNN typically consist of a series of convolutional layers. The activation function commonly used is ReLU layer, and it is subsequently followed by additional convolutions such as pooling layers, fully connected layers, and normalization layers. All these layers are referred to as hidden layers because their inputs and outputs are masked by activation function and final convolution. And if we see here, this is the architecture of a CNN or how the CNN works. We have an input image and we have a convolutional layer, pooling layer, and while it comes to classification, we have fully connected layer and an output layer. So in feature learning, it is nothing but learning the pixel information from the image. The feature learning happens in convolution and pooling layers. After learning, the classification happens in fully connected layer and the output is shown in the output layer. This is about CNN. Coming to Fast AI, Fast AI is the first deep learning library provided by Fast AI community, and it provides a single interface to all the most commonly used deep learning applications for vision, text, tabular data, time series, and collaborative filtering. It mainly supports transfer learning through pre-trained models. This process is faster and provides better accuracy. In the following example, I have used Intel image classification dataset from Kaggle and I will be applying CNN and Fast AI on that. And personally, I feel Fast AI is a better approach since it is faster and gives a better accuracy. So let's see the example. The first approach is the convolutional neural network approach. And to save some time, I've already run the notebook and I'll be demonstrating with the output. As the first step, I've imported all the libraries. And here I have set the path with the folders containing images. Here we have 3 folders, each for train, test, and prediction. I have used the glob module. The glob module is used to retrieve paths or file names matching a specified pattern. So here we can see the training data with the folders, validation data with the folders, and testing data. Code is a dictionary used to store the classes. Before building a model, we should always prepare the dataset by pre-processing. Here it is common to expect the sizes of the images will be different. So we have to resize all the images into one size. To do so, let's see the sizes of all images and then decide. As we see here, in the training set, most of the images are of 150 into 150. In the testing, most of the images are 150 into 150, and in the prediction too, most of the images are 150 into 150. So just to start off with and see how it goes, I will be setting the size of all the images as 100 cross 100. So let's resize all the images to this size using OpenCV. OpenCV is a library of programming functions mainly aimed at real-time computer vision. So after resizing all the files and train, let's plot some, and these are some of the images in the training folder. If we can see, the building has been labeled properly, the street has been labeled properly, forest is also labeled properly. So next we resize with the test folder and the prediction folder. When we read digital images using library, they are represented as NumPy arrays. So it represents the shape of the image. By converting it into NumPy, we can make faster operations on numerical arrays. So here we are converting the data into NumPy. Now the data is ready and let's see modeling. Here I've used 5 convolution layers: max pool, dense and dropout to reduce overfitting. To learn more about the parameters, I have attached Keras documentation. Please go through it. Now we have defined the model, and the next step is compiling it. After compiling, we can check the summary of the model. Model summary gives a view of what happened in all the layers. After compiling, we have to fit the model with the training data. For the model to learn, and we can specify the number of batches to train. And I have specified 20 epochs. An epoch refers to one cycle through the full training dataset. The batch size is a number of samples processed before the model is updated. Size of a batch must be more than or equal to 1 and less than or equal to the number of samples in the training dataset. Number of epochs is usually more than 1. So we fit the model with the training data with a batch size of 64. So after 20 epochs, we can calculate or evaluate how the model has been trained or how it has learned using evaluate function. So if we see here, the model has given a test accuracy of 82%. So it's a good accuracy, but let's see how it predicts on the test set and the prediction array of images. Here we are plotting some predictions. So the glacier has been classified correctly, the forest has been classified correctly. Let's see, building has been classified correctly, street has been classified correctly. So this looks good, but to improve the accuracy, we can always do some hyperparameter tuning. So this is about CNN. Now let's see using Fast AI. Fast AI runs on top of PyTorch. Initially, I have imported all the libraries and I'm checking for the directories present, and this as the same process I've set the path to folders with images. Fast AI will not work without validation datasets, so we have to make sure we have one by splitting the dataset. In the next step, we have to create a data bunch object. A data bunch is an API in the FastAI library which helps us to build data pipelines for the models. There are a lot of subclasses, so make sure to use the appropriate one. Here I have image dataset, hence I will be using image data bunch. We can provide parameters like path size, image size, and dataset transformations. So I'm providing a batch size of 50 and I'm resizing all the images to 150. After this, we have to normalize the data by using normalize method. And here are some of the images. Now for modeling, I will be using CNN Learner. The CNN Learner factory method helps you to automatically get a pre-trained model from a given architecture with a custom head that is suitable for your data. Here I am using ResNet model, and the metrics would be accuracy and error rate. After defining, I will be using fit one cycle with 6 epochs. The one cycle policy allows to train very quickly, and it's a phenomenon termed as super convergence. So here we get train loss, validation loss, accuracy, error rate, and the time taken for each epoch. So as we can see, the accuracy keeps increasing as the epochs increase. So here we have got 91% accuracy, which is really good. So let's save the model as it is. Now let's use classification interpretation. Classification interpretation provides a confusion matrix and visualization of the most incorrect images. We can analyze the results using this classification interpretation. And using that object, I am trying to analyze the most confused images that the model found confusing. So that would be glacier was confused to be mountain, buildings to street, etc. So to increase the accuracy, I would be changing the learning rate. So for that, I'll unfreeze the model and again change the learning rate and run the model once more. So after changing the learning rate, we can see that the accuracy has improved to 93. It's really good. So I will be saving this model too. So after saving the model, we can again analyze the results using classification interpretation and by plotting a confusion matrix. And here I've plotted a confusion matrix, and as we can see that most of the images have been classified correctly, but still the model was confused in analyzing images and classifying them. So for this we'll have to go in depth and see if the images were labeled properly. Sometimes if the images are not labeled properly or labeled incorrectly, that in that case the model will learn whatever is there and that would be wrong. So this is all about fast AI approach, and I will be attaching some references in the description. Thank you for watching and your time.